We know the grid is undergoing massive change, which creates massive opportunities for local energy. The Energy Changemakers podcast offers rich conversations with industry leaders to help you and your company capture opportunities to build the decentralized grid. I'm your host, Elisa Wood. Welcome to the Energy Changemakers podcast. Hey everyone, Elisa Wood here from Energy Changemakers. So a lot of people are predicting huge increases in power demand by data centers. Others, however, say those numbers will fall as data centers become more energy efficient. Which is true? And what will it take to reduce energy demand significantly from these new great big energy users that are showing up all around the US? I decided to take these questions to Mike Slevin, a business unit manager at Fluke. He's got a unique perspective because Fluke is a company that specializes in electronic test, measurement, and monitoring equipment. They work with a lot of data centers that are trying to become more efficient and trying to figure out if they should install microgrids, solar, or other forms of on-site energy. Here's what Mike had to say. Hey, Mike, thank you so much for being here today. We had a discussion a couple of weeks ago that was fascinating, and I really wanted to bring it to our audience. So where I'd like to start is by talking about energy efficiency in data centers. And the reason I want to start here is because, we're hearing a lot of big numbers about how much power will be required to meet the need of AI in data centers. And there are some folks who are saying, I'm not so sure. I think that we're going to see more efficiency come into play in the data centers that will curb the need for this much energy use, much like we did with PCs as they evolved. So I'm curious, from Fluke's perspective, how real or how overstated are the efficiency gains we're hearing about? Like, what do you see as the big misconceptions out there about efficiency in data centers?
I think from a Fluke perspective, honestly, we really hope those efficiency gains are real. The draw that data centers have on the grid right now and what that's meaning in terms of sustainability is obviously a really key topic and key consideration. And as we scale and as the footprint of data centers and the capacity just gets bigger and bigger exponentially, it's having a notable impact. So I generally personally hope that these are real and we can recognize them. But I think how we get there and how long it takes us to get there, that's probably a bigger question for us. We know that as we speak to some of our kind of leading customers in this space, that they're investing heavily and that they're starting to see some green shoots, both in terms of efficiency, but also sourcing that energy. But actually, more often than not, what we're discussing with customers today is what I call the micro gains. So these are often the marginal gains they get when they revisit their existing infrastructure. Obviously, the biggest consumption factor is energy and power, and that's largely coming in from the utility space at the moment. So we look at efficiency optimization in the utilities. How can that power be brought to the site and how is it transferred? But also more than that, we look at it within the actual kind of gray space and white space of a data center. Fluke's history is obviously with electrical test and measurement. That's what we're known for globally. So we often will have support technicians who are looking for poorly managed, poorly maintained equipment. In electrical equipment, obviously anywhere you get a poor connection, that causes resistance. And resistance is a measure of energy loss into heat. So the thermal imaging cameras that we produce are used by technicians to identify heat signatures. And by correcting those, you can get marginal gains on energy efficiency. Same with motors. The cooling that happens around data centers requires huge amounts of motors to move the air around, both in the white space and the gray space. Anytime you get a motor that's reaching the end of its life, it becomes less efficient. And that motor will produce vibration. Vibration is energy loss. So all of these things are individually relatively small, but collectively have a very big impact on the overall kind of PUE metric that data centers operate to. And if you can start addressing some of these and have a more, what we call a predictive or preventative maintenance strategy that addresses some of these, today that's where a lot of those conversations are and actually where the real world gains are happening. So I think what we'll see is this hybrid where in the short term, we are focused on what we can do today to optimize the existing infrastructure that's in place And then as we think about maybe over the next couple of years, replacing that infrastructure or deploying new infrastructure that enables data center operators, particularly kind of hyperscales, large colos, to have a more efficient operating model altogether.
That fascinates me. What you're saying fascinates me on a couple of different levels. One is, I think we could have just traded out the word data centers for manufacturing facility, because it sounds like what we've been hearing for years, right? This is basic energy efficiency. And two, I find it fascinating because I think when we hear about data centers becoming more efficient, we think of some kind of amazing new technologies that will be applied. But what you're saying, at least initially, is no, we're doing the standard things to make these facilities more efficient. But are there down the road some big magical idea or technology? I mean, are data centers looking at ways down the road that would significantly reduce their power use through something perhaps that we don't have really right now? Or is it more what you were just saying? Eventually, they'll need to change out equipment and new equipment is more efficient.
I think the honest answer is both. And maybe just take a step back to the kind of comment you made there about the manufacturing side of stuff. Yeah, we honestly see very close similarities in our discussions. What maybe varies is scale. Even in some of our largest kind of manufacturing customers, the scale that we see in hyperscale power consumption particularly is vastly different. So if you can make marginal gains in some of those areas, they result to be a much bigger overall impact on energy consumption, grid consumption than you maybe have in a manufacturing setting. I honestly believe also that there will be some breakthroughs. I think if we expect the trend in demand for AI and for services coming from data centers to continue at the rate they're going at the moment, the current infrastructure just doesn't support a continued expansion in the way of working that we do today. So I think we'll have to find novel and breakthrough ideas. We talked a little bit earlier about one of those, which is this idea of, okay, if we're using solar as an augmented energy source for data centers today, but with general fact that solar uses DC voltage and most data centers today, the infrastructure uses AC. So obviously there's a conversion factor, the transformation, and there's energy loss that happens in that transformation. I think there's been DC equipment in data centers for 20 plus years, but certainly if you were to make it more prolific, one idea would be to have an end-to-end DC voltage stream all the way from the initial solar right the way through to the actual servers. That in itself would significantly reduce some of the inefficiencies that you get. So I think there are definitely novelties that we're going to see come up. What I think we're not clear on yet is which of these is going to be the prolific and the extended solution that allows a data center to maybe cut by 20, 30% its energy consumption versus today. But it's certainly something that our engineering team are investigating. We have innovation engineers out partnering with data center operators to understand where they're investigating and how actually we can leverage Fluke's experience of power and try and help them find optimum solutions.
I'm assuming it would be optimal for, if you're going to go DC, you would do it when you're constructing the data center. What does it take to go in and switch over to DC if it's an existing data center? Is that feasible? Is it economical?
I think feasible, yes. I think economical, maybe short term, is less so. But what we do know is that the capital cost of replacing AC infrastructure with DC is relatively high up front, but the potential savings over a 3-5 year period could make that much more attractive to operators. But I think also it's what it enables. So if we think about it backwards, having a DC infrastructure in place often gives you much better or more efficient access to things like solar. And we know how important sustainability and sourcing sustainable energy is to data center operators. So it could in itself become an enabler to having a more sustainable grid infrastructure. And I think it will be very interesting to see how this plays out. But having said all that, I still think in the short term at least, and short term could be a few years out still, it will be greenfield sites. It'll be the new builds where we see that happen first, just because that cost of deployment is that much lower.
Speaking of the energy, the power sources, we're seeing a growing interest in power sources like microgrids for data centers, big microgrids. I don't know if you can call them microgrids anymore, but
When does the word micro not mean micro? Yeah.
exactly. What's driving the shift? Why are we seeing data center developers, operators talking about on-site energy, microgrids, even in some cases off-grid? What's driving that?
What we hear when we speak to customers is really two things. So I think the first is this idea around sustainability. So given the amount of energy that's consumed at the moment and that rate of consumption increasing, having more sustainable sources, and sometimes that's microgrids, sometimes that's carbon offset, but generally speaking, it's around this idea of improving sustainability for the long term. Now, I also think there's an alternative and maybe arguably more operational or more practical reason, which is availability. So quite often, given where some of the data centers are located, that grid availability is just not either present or sufficient, and therefore at least partially augmenting with microgrids or even completely being off grid is a necessity. And I think it's that combination of necessity and drive for sustainability that is resulting in this rapid adoption that we see. Maybe the third thing I would say is it's also the efficiency. So we're seeing technology, particularly in areas like solar, accelerate, and it's a bit of a kind of chicken and egg situation. Data centers require significantly higher efficiency, or else some of the data centers we're working in, if they were fully powered by solar, you would be requiring huge acres of land to be allocated to the solar farms. So I think these are becoming much more efficient as the need becomes higher. And likewise, as they become more efficient, it becomes more cost effective, largely more acceptable to have higher percentage of power coming from these microgrid installations.
I want to talk a little bit about solar more in a minute, because I know you're doing a lot there. We're talking today on a Friday afternoon. It's very late for you. You're in the UK. I'm here in the US. And I know a lot of the work you do is global. Are you seeing the same interest in sustainability in the US now as you maybe are seeing elsewhere, or as you may have been seeing previously in the US? Has the drive towards sustainability changed at all since our federal government here has changed and changed the messaging around energy?
I think the trajectory hasn't changed. I think the trajectory remains largely similar. Maybe it's the velocity at which we're moving along that's changed. And again, I think that's because the need for sustainability is not tied to the term of a government. I think there is a general recognition that sustainability is going to be critical if this capacity rollout is to increase. And because it's not just about environmental, social, there's also real operational needs. So I think the overall trajectory is consistent, but we have definitely seen sort of notable slowdowns in some areas. Could be correlated, could be caused. I think that's probably too early and too difficult to say, but we don't expect there to be a kind of full-time stop. What we do see is even where maybe in the US, we've seen a slight slowdown, that's more than offset where we've seen adoption in other areas. So particularly areas in the Middle East, in Europe, we've seen increasing adoption of solar and microgrids, and that's where we continue to see growth that we're supporting with our tools today.
Interesting. So Fluke is involved in testing and monitoring. I'm curious if there are unique challenges for microgrids compared to grid power in your work.
There absolutely is. So a couple of things that vary for us. Firstly, it's higher voltages, as we talked about a minute ago. So in order for the solar to work for data centers as an example, but not just data centers more broadly, the voltages just get consistently higher and higher and higher. So a key area of innovation for us is how do we measure accurately and consistently at those higher voltages? And the other thing that Fluke really stands for more than anything else is safety. Our whole mission is to make sure that we keep the world up and running and that we ensure the safety of the people that use our tools. And as those voltages get higher, it's ever more critical that we make sure our tools are the things that keep technicians safe. So I think that's one big area for us. The other thing that we're seeing is as solar becomes a power source for more critical infrastructure, data centers is one example, but I could think of many others. We see this in the healthcare sector. We see this in a number of other sectors. Yes, there is often battery backups that act as an intermediary, but it becomes more critical that these installations are highly reliable. So what we've seen is a greater increase in technicians wanting tools that are focused not just on kind of ad hoc troubleshooting or commissioning, but actually are focused on reliability. And where we've had for many, many years now kind of preventative maintenance strategies that happen in the manufacturing setting, in industrial settings, we're now seeing this being rolled out to solar farms where we're seeing much more routine maintenance inspection, whether that's using thermal imaging cameras, whether that's using drones. We work with robotics companies that attach our technology onto payloads on the back of robots and drones. All of these are techniques being deployed to try and improve uptime, reliability, and efficiency of these different sources, but particularly solar.
What are you looking for to ensure that the solar is operating in the most efficient manner? What kind of maintenance may need to be done?
A couple of things, really. Obviously, the first thing is a panel. So we have a range of solar tools. One of those examples is IV curve tracing. So we have tools that allow you to do IV curve tracing, and that really gives you a measure of efficiency of that panel. There's lots of things that can ultimately affect efficiency, from installation, from good maintenance and cleaning of those panels. So we look at how efficiently those panels are operating. The other thing is, when all of the panels are wired together, you have to make sure that they're correctly wired. If they're incorrectly terminated or connected together, each of those connections represents a failure point. And depending on how the wiring works, you can end up having a significant loss in overall power output from those strings due to poor electrical or incorrect electrical connections. So that's a couple of examples. The other big thing for us is when we think about transformers, all that energy is ultimately going through a series of transformers. And again, those have to be installed, maintained correctly and optimally if we want to maximize our efficiency.
Very interesting. So let's go back to solar a little bit more. Two things I have heard frequently are, one, microgrids don't have enough energy density for a data center. And I think maybe that's changing a bit now as the microgrids are getting a lot bigger. So that's one challenge I've heard a lot. And the other challenge I've heard in terms of solar is similar, that solar doesn't have the consistency to be enough for a data center. Do you find those things to be true or not true? I know you're seeing a lot of solar. We were just talking before you got on about solar for data centers in, I think, the Middle East. So you're seeing a lot of it. So why, and do these challenges come into play, or are they being overcome?
I think that it's definitely a challenge today. So there are a number of data centers across the world that are almost exclusively solar or microgrid powered. And they tend to be less common in the hyperscale or even large kind of co-location data center space. What we see there is really they're used as supplemental or augmented. And really that's because of their ability to give enough capacity to fully and permanently power, as well as, again, you mentioned it, I'm from the UK. I can tell you if I look out of my window here right now, you probably wouldn't want to be powering my house, let alone a data center, using solar on its own right now.
Foggy today?
It's a little bit of a cloudy, damp day here in the UK. It's also regional. Whereas if I think about where some of the projects that we're working on right now, obviously in and around the southeastern US, I was in Saudi 2 weeks ago. There's no shortage of sun in Saudi, and therefore it's much more feasible to think that we could have a higher percentage of energy coming from solar in those areas than it might be. So I think there's definitely a regional difference. I think the other thing is how we think about energy storage. So again, the storage of solar energy is making huge leaps and bounds. It would have been wholly impractical, maybe even as few as 5 years ago, to think about storing the amount of energy you would need to power a hyperscale or colo data center from solar. But as battery technology becomes more efficient, the size becomes smaller, it becomes more realistic to manage that. Then I think the final thing is we think about, we call it harmonics. In the electrical system, you have harmonics and superharmonics. These are things that we have to understand better. We have to understand how, when you have a data center at the scale that it is, how do you understand and then more importantly, manage some of those factors to avoid them causing uptime or reliability issues? And I think as our knowledge grows, as innovation happens in both the infrastructure, but also the tools, we'll get much more able to manage that more effectively. And it's much more then achievable to have a higher percentage of energy coming from micro and solar.
Is there a part of the world where you see the most innovation occurring in regard to these technologies? Is it the US, Europe, Middle East? And how do the projects differ by region? I know, of course, sunshine comes into play quite a bit when you're talking about solar. Are there other factors as well?
Yeah, I think so. Probably overall, I would still say the US. So even though we've seen that landscape change and shift a little bit, in terms of innovation, I think it's still US. And I think part of that reason is the data center operators themselves. So if you think about the big logos, many of these are still US based. And that means naturally a lot of their innovation centers and engineering work is still coming out of the US. However, we see pockets of high-end innovation and breakthroughs happening all over the world. I was at a conference recently in Europe, and we were talking about how we think about using hydrogen like as a source of energy. And again, that's coming through a couple of European projects. And that's just starting to get to a critical mass now where you can see it's got the potential to scale. So that's another technology that we're looking at. And again, that would work particularly well, I think, for where you want off-grid installations, but where maybe solar is less prevalent. Could be the UK, this actual conference that was happening in Scandinavia. So again, an area where there's a little bit less access to sunlight than in some parts of the world. So I think generally speaking, US is definitely very strong, but we see pockets of this really across the world.
And how much does regulation and electricity price drive these differences?
So I think right now, price is definitely a big factor. But I think regulation is increasingly important. And it's not just regulation. There are sustainability targets that data center operators are governed by and sign up to. But I think more than that, there's also the kind of social importance of this. I think as soon as you start doing the math on how much energy is being consumed and what that really means, and you think about that compared to other consumption, there's almost as much that concern over perceived image and brand as there is from government regulation. Having said all that, I think what we will see is governments take a little bit of time to catch up, but they are very much getting there in terms of realizing the impact that this is having on the grid infrastructure in regions. So I think we'll see a step up in regulation happening. We're already seeing it happening, and I think it will continue to happen. And part of what we do at Fluke is we try and act as a kind of intermediary or an independent expert on some of this regulation. So we quite often will work with the regulatory bodies to provide advice, guidance in terms of best practice for areas like solar, but also we were talking with a couple of experts only a few weeks ago around harmonic analysis and how we could think differently about different bits of capital equipment and how that affects efficiency within data centers when we think about harmonics and superharmonics. So those are areas where we try and influence and make sure that we're helping be a solution to a problem.
Yeah, I'm in Virginia. So one of the big issues here right now
Yep.
is who's going to pay for the power? Will the average person, average electric ratepayer, be covering the cost of the data centers? And lots of talk about changes in tariffs and whatnot to get it going.
It's also the opportunity cost. You mentioned you're in Virginia. So if you have a new data center open up locally, even if someone else is paying for the direct infrastructure, what happens as that scales? Who pays for the indirect costs or the externalities of that? And that's where I think we'll see more and more.
Yeah, we had another guest who talked about how easy it is, either inadvertently or intentionally, for a utility to not include data center costs, such as certain transmission charges and things that sort of wouldn't necessarily easily show up when you're analyzing what costs the data center brings to the system. So a lot to unpack there over the next couple of years, I think. I'd love for you now to produce your crystal ball. Looking ahead, what's the biggest change you expect in data centers, their management, their energy, say over the next 5 years?
One of the big things for me is scale. So we've seen this in the last maybe 2 to 3 years, that the scale, and this is driven by AI, obviously, but it requires a scale of infrastructure deployment that we've never seen before. And I think right now, primary focus of data center operators is really get to that scale by any means necessary. What I think will change over the next 5 years is the race for scale will probably reduce slightly, but there certainly won't be an ability to say, hey, we're going to put speed to uptime or speed to availability above and beyond anything else. So I think we'll see an inflection point in the next probably 2 years where there's a resetting of the balance between speed to get to uptime and availability to a more balanced approach that says we have to have a sustainable, predictable, responsible strategy if we want to power at this scale. And I think that's going to drive huge amounts of innovation. We're already seeing this in terms of investment. The level of investment going into engineering and innovation in some of these more sustainable technologies, DER technologies, has exceeded in the last 2 years what it was in maybe the 5 years before that. And I think we'll see that investment level just continue to grow. I also think what it will do is force us into a position where we have to think bigger. We have to be more breakthrough than we have been. I was talking to a colleague of mine who was talking about nuclear as a solution. You end up in a situation where you could even have like micro nuclear plants. Maybe for some that's a scary thought, but that's the level of disruption in our thinking that I think we're going to have to get our heads around in the next 2 or 3 years. So I wouldn't be surprised if in 5 years' time, there's not one kind of perfect solution or universally deployed solution. I think what we'll see is much more a case that data centers and data center operators are having to think on a case-by-case basis about what the optimum balance is for each data center that gets built And I think the other thing that we'll see is, what does this mean for existing data centers, for our kind of brownfield sites and for legacy installs? Are they allowed to continue and run as they were, or is there going to be a push to actually make these more efficient? And whether that comes through replacing the infrastructure internally, or does that come from thinking about entirely new ways to power these data centers?
So we may see a revolution in the older data centers as well going down the road.
Yeah, I think it will start with the greenfield sites, the new builds, but we can't ignore the pretty large install base that exists today of brownfield existing data centers that collectively are still massive energy consumers. And in many cases will simply just be less efficient than their new build counterparts.
Let me just jump back a little bit to something you said a little bit earlier. You said there's this shift you expect to see. Right now, it's about the hyperscalers, and that may change in a couple of years where building these big data centers becomes less important. What do you foresee driving that change?
So I think a couple of things. What maybe geopolitical situation is one of them. The thing with very large scale, hyperscale data centers is they're very much location based, and obviously they're processing huge amounts of information, but they do so centrally. And that assumes that we can continue to reliably transmit information. And I think in the last kind of couple of years, at least, we've seen that the geopolitical situation can turn on a dime. And I think that will cause organizations and governments to rethink their strategies. Also, I think we will need to increasingly focus on latency and connectivity. And there, wherever you're transmitting data over very large distances, that becomes a bigger consideration. So maybe having more localized deployment of data centers is going to be a bigger consideration. But with that, you then have to think about how you deploy the infrastructure, how you deploy not just the construction of the building, but also grid infrastructure and grid connectivity. And it's also, what's the leading and what's the lagging? So does the infrastructure availability determine where you build data centers, or do you start thinking about, hey, this is the optimal place for a data center, but now I have to think about the power and cooling, etc., as a secondary?
Which is why I think we're seeing that drive toward more off-grid power for data centers now. In the US anyway, sometimes it's just too hard to find those places now where it's easy interconnection and quick to build and all that kind of thing.
Yeah, you've got to find somewhere with the land, the power, you suddenly put all of these different attributes on a list, and you realize how difficult it is to find a location that ticks all of them.
Right. So if you had to give grid operators one piece of advice to prepare for what's ahead, what would it be?
Don't forget to sweat the small stuff. We've talked about some really big topics here in the last kind of half an hour or so, and really important big topics. And I think these are really front of mind for operators. It's also always too easy to get consumed by these really big things. And actually, so often is the case that it's the smaller, more marginal things that when you do them well are what gives tangible, impactful results. And I think this for me is an area that in the customers I'm speaking to and in the last couple of kind of conferences and events I've been to, we've talked about at length is if you get the basics right and we start thinking about those effectively now, those are what drive real, tangible impact and will give us results in the next couple of years while we continue to work on the really big things. Yeah, don't forget to sweat the small stuff.
Okay, very good. Wonderful. This has been a great conversation. Appreciate it tremendously. Thank you so much for being here today, Mike.
Awesome. Thank you for having me.
Thank you for joining us today on the Energy Changemakers podcast. I hope today's conversation has inspired you to think differently about the role of distributed energy in our society. If you enjoyed this episode, please subscribe to our podcast on your favorite platform and consider leaving us a review. You can help us shape the dialogue around energy. Go to energychangemakers.com, subscribe to our newsletter, and join our community. Together, we can make a real difference in how quickly we can make our grid local, equitable, and clean.